Hi, this is Gracia from CSE department. My mini project topic title is Alzheimer disease detections using a deep learning. Uh, using a deep learning. So, Alzheimer disease detections is a progressive brain disorder that leads to a decline in the cognitive functions such as memory, thinking, and the ability to perform everyday tasks. It is crucial to detect this is early as it allows for timely interventions, educations about dementia, and better preparations for both the parents and the caregivers. Our project aims to develop a system that accurately identify the individual who may have the Alzheimer disease at the early stage. The problem statement of this Alzheimer disease is gradually diminishes a person's ability to think and remember, significantly impairing, opens up more clinical and options and gives the caregivers more time to adapt to changes associated with the disease. Our goal is to enhance the model's ability to differentiate those without at the earlier stage. The scope of the project is to create an automated system, Alzheimer's disease, using a medical imaging data, specifically brain MRI scans. Our objective includes improving early diagnosis for timely interventions, facilitating efficient large-scale screening process, and supporting healthcare professionals in the decision making, reducing the cost associated with Alzheimer's disease diagnosis. The methodology used here is data collections, data processing, model development. And data collections, we gather the diverse data of brain imaging scans from an individual with and without Alzheimer's, collaborating with the medical professional to ensure the authenticity. Data processing, we implementing the technique to clean and standardize the image data, enhancing model robustness. And the architecture diagrams of this is the architecture diagram. Here, the systematic approach is essential for generating reliable detecting result. Yes, it is an input and it is the convolutional layers and it detects whether the person has Alzheimer's disease or not. And the algorithm used here is we utilize both the CNN and recurrent neural network, which is RNNs in our project. The CN models processes 3D image data like MRI scans, patterns associated with Alzheimer's. Meanwhile, the RNN models handle sequential data, which is crucial for capturing changes over time in a brain activity. It is a design for use case diagram of like you log in, pre-processing, contract enhancement, design class data. It is a sequential diagram. So it's a code of implementations. In our implementations, we build deep learning models using Keras. The model consists of several convolutional layers, uh, followed by the pooling layer and a RNN layer to process the data efficiently. This architecture is designed to enhance the model ability to classify MRI images accurately. And it's a code to detect whether the person has Alzheimer or not. An output is a result of our model indicate promising outcome in predicting Alzheimer's disease from brain MRI images. The model's predictions will contribute early detections, which is vital for patients' care and interventions. It's predicted values. It's a model of a person with Alzheimer or not. Let's see about the code implementations. Here the this layer applies a 16 filter uh, of size 3 cross 3 to the input image. The strides parameter is a set of 1 comma 1, meaning the filter moves 1 pixel at a time across the image. And the activation function used in the RLU rectified linear unit, which is introduced to non-linearity to the model, allowing it to learn complex patterns. Kernel initializer. It is normal using a method that helps faster convergence during the training. An input shape, which is 128 cross 128 pixels with 3 color channels. And next, the max pooling 2D layer. This layer reduces the spatial dimensions of the features map by taking the maximum values in each 2 cross 2 block. The downsampling helps to reduce the number of parameters and computations in the network while also making the model more robust of variations in the input. Second convolutional block. This one is a second convolutional block. In this block, we increases the number filters up to 32, and this allows model to learn more complex features from input as the data progress through the layer. Max pooling 2D layer, similar to the first block, this layer reduces the spatial dimensions of the features mapping, helping to retain the most important feature while reducing computational load. The, then the third convolutional, it is 128. It is increases up to 128, allowing model to capture even more intricate patterns in the data. And again, this layer performs downsampling, further reduces dimensions of the features map. Then flattering layer. This layer converts the 2D features map from previous layer into a 1D vector. This transformation is necessary to connect the convolutional layer, fully connected layers that follows. A dense layer. Then the dense layer, these are the dense layer. The layer is fully connected, meaning every neuron in this layer is connected every neuron in the previous layer. It has 128 unit and uses the ReLU activation function, allowing the model to learn complex relationship between the features extracted by the convolutional layer and the output layer. This layer has a signal unit. This layer has a signal unit, sigmoid activation function. This is output as a value between 0 and 1. This is suitable for binary classified tasks where the output can be interrupted as a probability of input image being classified as a Alzheimer's 1 or non-Alzheimer's which is 0. And this was the output, sample output. It's a predicted values. So the conclusions of my project is a project provides a proposed method utilizes a convolutional neural network and recurrent neural network architecture for the early detections of Alzheimer's disease from the brain MRI images. The use of advanced neuroimaging techniques such as MRI allows for the extractions of shape features and textures from the hippocampus region, aiding in the detections of Alzheimer's disease. And this was the future work. We will investigate other source of in which social network can be extracted and carry out more insignificant analysis. Thanks.